So the presentation tonight is really covering regenerative agriculture, more in what the term means than everything that is in fact like all the practices. That is going to be covered throughout my soil health series that goes every month throughout this year. This is the second year I've done this series. And so last year it was just on soil health. This year I've broadened the scope for regenerative agriculture because that kind of is an umbrella term that covers soil health as well, and I wanted to broaden the topics. So that presentation outline, first I'm going to kind of discuss what's the difference between sustainable and regenerative agriculture. Why is regenerative agriculture becoming kind of that term du jour? Lots of people are using it now, and kind of cover that and the emphasis of what that has, why that term is kind of being used often now, how to implement regenerative agriculture practices on your farm in a basic general sense, and then where is regenerative agriculture most beneficial. So first on to that topic about what's sustainable agriculture. And so when we talk about that, often that is a term that a lot of people misunderstand what it means. Often a lot of, especially lay people aren't in kind of that world of sustainable agriculture research, often equated to kind of something like organic agriculture. And really, in actuality, the definition in this simple definition in the Farm Bill, it's been defined, it's a much larger definition, but in its simplest terms, sustainable agriculture is the production of food, fiber, and other plant and animal products using farming techniques that protect the environment, public health, human communities, and animal welfare. And this form of agriculture enables us to produce healthful food without compromising future generations' ability to do the same. Essentially, that's kind of the impetus of what that is meaning, but here's really the conceptual diagram of what that entails. And it is when you're thinking of a management practice on a farm, to be sustainable, your decision needs to take into these three pillars: the ecology or the environmental impact, the society or societal impact, as well as the economic impact of that particular decision. And so when you balance all of these things, you end up here at what we call sustainability in the center. A three-legged stool is also another way to kind of think of it. So when we switch gears from sustainable into regenerative agriculture, first, the term is not defined yet. It is fairly new in its term. The practice is not new and has been practiced by indigenous people for thousands of years. But the current form is lots of people are using this term as a term, and yet we don't know exactly what it means. So when you speak to 5 different people about what regenerative agriculture is, it is likely you'll get 5 different definitions. And certainly there are many websites touting regenerative agriculture, many businesses doing that, as well as researchers. Yet some either don't define it, or when they define it, it's different. So here's 3 definitions that I've pulled from a research paper that was kind of an overarching look at the term regenerative agriculture. And this one here, a system of farming principles and practices that increases biodiversity, enriches soils, improves watersheds, enhances ecosystem services. This is a very ecologically minded definition, looking at just the kind of more soil-based soil health practices. And it's different from sustainable in the fact that it actually is talking about not just sustaining it at whatever level it's at, but actually improving it. Then we have the second definition: a long-term holistic design that attempts to grow as much food using as few resources as possible in a way that revitalizes the soil rather than depleting it, while offering a solution to carbon sequestration. So it is similar to the previous definition, however, it is now added in maybe climate mitigation techniques through carbon sequestration. And then lastly, we have a form of enterprise that incorporates a community of people engaged in civil labor to produce and consume the food and land and landscape and amenity that they collectively decide to grow. This definition doesn't talk about soils or farming practices really at all. It doesn't talk about anything that we think of often when we talk about regenerative agriculture practices. Instead, it broadens the definition to society. And likely all of these definitions are getting at something that's a broader base of regenerative agriculture. And we need all three of these definitions to be incorporated, I think, moving forward. We want to think about it. And just last week, I had the pleasure of listening to a lecture by Dr. Ratan Lal, and he, in fact, actually had this definition here. Why regenerative agriculture? So systems-based regenerative agriculture reconciles the need to produce adequate and nutritious food with the necessity of restoring the environment and making farmland a solution to environmental issues through eco-intensification and producing more from less. And so that's really kind of a summation of all of that. Sorry, I was admitting someone else to the room. And there are many terms that are also used often interchangeably, as people try to do, with either sustainable agriculture, regenerative agriculture. And the list here is likely not an exhaustive list. And when we look at often many of these different terms that are thrown around in these definitions, here is what we call a word cloud. And so if I take all the words that are used generally to describe regenerative agriculture, throw it in this word cloud, the words that are the largest in the cloud are the ones most often used. And so the two largest words are natural systems. And so I kind of like the fact that that fell out that way, because really, in fact, if we emulate a natural system, we can get better at kind of where regenerative agriculture is trying to target. It's trying to emulate the natural world because Mother Nature seems to have figured it out all by herself. So we have to take a systems approach when we're talking about regenerative agriculture or anything that is going to help enhance, enrich, increase our natural world and our ability to be able to feed those on the planet, and that is not just humans, and also ensure that we don't degrade our soil systems. So we need, in taking this systems approach, looking at the productivity, because we need to ensure that we are producing enough. That's that societal piece, kind of ensuring that we have enough food for all. Because one, we have lots of people living on the planet, and not all of those people have an equitable amount of food, as well as more people that will be on the planet. Then we need the stewardship part, that's looking at ensuring that we have that land that can be passed on to the next generation, and caretaking that land, perhaps even renaturing some spaces. Looking at profitability, that's that economic part. If our farmers can't make a livable wage and they can't feed themselves, they definitely can't feed the rest of us. So that is an important component. And that really goes along with this last one that is often forgotten, that is looking at the quality of life of those working in our food system, both our farmers, our farm workers, as well as those that are cooking and providing the food there as well. And so when we talk about sustainable agriculture, regenerative agriculture, I often like to show this diagram, and it's not something you need to study too well. It's just that when you're talking about taking a systems approach, it isn't that easy, as those three little bubbles in that Venn diagram. It looks a little bit more like this, and this is just, in fact, actually looking at the just the crop production side of it. We're not even broadening it out to the food system as a whole. And we have still the three pillars. We have the economic part, we have the environmental quality part, and we have the society part. But you see how everything is linked to everything else, and you can kind of look at how one thing actually influences the other. And so when we start to talk about a practice, we have to understand the impact of that practice on not just that one thing that it's meant to impact, but where else is it connected throughout in the system. That's what systems thinking is looking at. And so it's very important that as we begin to come up with solutions, that we understand the impact of the solution throughout the system. Now I'd like to move on to the kind of why regenerative agriculture is that really important term right now and being used. And likely you can all guess why it is. And we're kind of having a rough time right now. Mother Nature is a bit on life support. We have record droughts leading to wildfires, storms that drop 15 inches of rain in one location in a short period of time, leading to flooding. And just a couple of years ago, we had 2 floods and 2 droughts in the same season, just in this area of North Carolina. That's crazy. So that's likely why it's kind of pushed to this. We need a solution, and regenerative agriculture seems to be a solution that likely might move us to a better direction. And often this is a really great example. Well, here's what regenerative agriculture can do when we start to caretake the soil. And we have that regenerative agriculture, and the image on the right and in the left is that conventional agriculture. This is when we're talking about an animal-based system here, where you're continuously grazing the animals on that left-hand side, or are you moving the animals and allowing them to be closer together, more intensively grazing, but moving them more often, which leads to a better stand of grass in this case. And so really it's about taking care of the soil and leaving the soil with something growing on it. That grass actually is able to catch the power of the raindrops and reduce the impact of that rain on the soil. And the roots, not only do they increase carbon, which feeds the microbial life in the ground or in the soil, but in fact, it actually leads to more water being captured and running down into the soil where it is most needed, compared to on the left-hand side, it's going to run off and lead to erosion, which has a whole host of problems with it because it carries nutrients and our vital topsoil with it. Just the other day, I read that we lose on average the equivalent of a soccer pitch amount of soil every 15 seconds, according to the UN's research. That's a lot of soil. And I think we need to learn how to, or figure out how to keep the soil where it is. And so where do we start? Well, there's lots of blames, lots of finger pointing, and I think it's mostly just starting where we are. And that is both those who are in the agricultural system, but also in our own backyards as well. So we have to actually, in fact, work in both spaces to help move the needle on with climate mitigation and ensuring that we are caretaking our soils. And so what can we do to implement regenerative agriculture practices? First, location matters. It's really important to understand that the soil beneath your feet is not the same as the soil, perhaps, under the feet of someone in a different state, a different county, even the next town over, and often it could be even the next field over. Just in North Carolina, we have 25,000 different types of soil. Across the world, we have 300,000 different types of soil. And within those types, there are multiple different gradients of soils. And so understanding what type of soils you're working with, because there may be soils that just aren't conducive to being utilized for a specific type of agriculture. And so using the agriculture practices that are a good fit for that soil type and in that location is an important consideration. It is not a one size fits all when it comes to soil. So to get started, on top of understanding what soil type you have, and that can be done using the Web Soil Survey, which is the NRCS online tool, figuring out, put in an address, and it'll tell you what type of soil is in that location. And on top of that, and more importantly probably, is doing a soil test. Because unless you understand the history of all of the things that have been done to the soil, without a soil test, you really have no idea how to move forward, what needs to be done. You know, every year we go to our doctor, you know, if you go, you get a blood test. Why? Because he kind of wants to see what's the lay of the land. He's looking for things maybe that you should be aware of. It's kind of the same thing with a soil test. If you're not understand what the acidity is, what nutrients are already there, you may over apply and end up creating more of a problem than a solution. And as I've mentioned, soils are very different. So here in North Carolina, where I am, and I know not all of you are in North Carolina, but even just in the state, we have vastly different soils. I mean, in North Carolina, we have 7 different climate types, and which influence the development of soil. We have hills, we have flat areas, and then lots of geographical history from thousands and millions of years that have formed the soil beneath our feet. And traditional for the Piedmont region, which is where I am located, we have very clayey soils. And in North Carolina, in many areas that have utilized animal manures as a form of fertilization, especially chicken and pig manure, you need to understand that often it is likely that your soils, if they have had that history of application, likely have very high phosphorus levels, as well as zinc and copper levels. And so understanding that through a soil test and what you have, you may not need to add any at all. And then just on the East Coast, areas that have heavy rainfall, and that could also be in the West Coast as well, in the mountain regions, you may have areas that have heavy rainfall. You're going to just naturally have highly acidic soil. It comes from the rain and some biological processes that happen when H2O hits the ground, because pH is a measure of the hydrogen that's in solution. And so rainy areas just naturally have highly acidic soils. Dry areas naturally have calcareous soils that are have a high pH or are more alkaline. So that is another reason why soil tests are important, because then you can know what you need to do to adjust that. Because if you're trying to grow something there, most plants, other than your acid-loving plants, like blueberries, who are super happy with high acid soils, you're trying to grow grasses or other vegetables, even some trees, they like a level of pH maybe higher than a 5.5, likely probably around a 6 or even a 6.5, depending on the particular type of plant. And so if your pH is, say, a natural pH around here of like 4.5, and you try to put a tomato in there or grass or corn or whatever have you, the roots won't even really penetrate deep into the soil. And the reason is the aluminum levels in the soil. There's the form of aluminum that is in the soil when your pH is below 5.5, in fact, actually burns the roots. And so they won't grow down in there because they actually get deformed and get what looks like under an electron microscope, it looks like the roots are burned. So before you plant something, by doing that soil test and making the adjustment well in advance, about 6 months to make that adjustment in pH, you can't begin to build the soil health and begin to have those plants hold on to that soil, because they won't even put their roots deep down to actually hold the soil in place. So this is what a basic, very kind of, it's not very granular, kind of lumped together, but this is a soil map of North Carolina. This is how very different it is. And of course, across the United States, it's also, there are other locations in the US that have very unique soils. It has to do with the topography, it has to do with tectonic plates and all sorts of crazy stuff from eons ago. But where we are in the Piedmont region is kind of this area. It's called the Triassic Basin. It notoriously has very, very high clay content. Like, you can make really great bricks, very hard to grow stuff in. And some places you can actually drill down as deep as 500 feet and find no water at all. And so perhaps if you had farmland in that area, you may want to grow grasses and graze something on there, but it wouldn't be conducive for perhaps maybe vegetable production. So there's a lot going on in the soils when we're trying to look at practices that build soil health and regenerative agriculture practices. And so when you're looking at a management practice, you're looking at all of these things, because soil has physical properties, like holding on to water, how dense it is. So that could be compaction. You have how fast the water goes in, how erodible the soil is, how easy it is to penetrate for the root to get down in, the texture of the soil, which is really the combination of sand, silt, and clay. And then water stable aggregation is really just its ability to take a raindrop. And often that actually is a good measure of soil health. And it's because the higher microbial life you have in the soil, the more stable it is, or that aggregate stability increases. When we look at the chemical nature of the soil, we're looking at the base saturation, which is essentially just a measurement of how many bases, which are your potassium, calcium, magnesium, are on the clay particles. You have pH, which is your measure of acidity. Cation exchange capacity is really cations, or positively charged ions. It just means how many spots there are can hold those things that are positively charged. And often that's a great thing, because higher cation exchange capacity means it's going to hold on to nutrients and keep them from leaching away. Then, of course, your nutrients that are available there, because they are from, or going to be released from, both the microbial life, but also from the minerals that are there, and the microbes are breaking those down, as well as other processes. And then the biological component, that's the living component in the soils, and that greatly influences the yield, the amount of nutrients that are being released, how much carbon can be stored within the soil, as well as, really important to consider, the diversity of our microbes, and not just how many different types of microbes we have, but how large are those populations within the soil as well. And those are all things that go into increasing our soil health, increasing those properties and making them better. So how do we do that? Well, first of all, keep it green. It's not easy being green, but it's important. When we have living plant life on the surface of the soil, it helps to allow rain and water, moisture to go down into the soil. It is actively pulling carbon from the atmosphere, because plants do this amazing thing. They photosynthesize. And when they do that, they are actually, in fact, pulling in carbon and making it part of themselves. And not only is it going into the above ground, but it is also getting stored down in the ground. And then, like many of us, we all like to eat different things. Well, microbes also like to eat different things. There are ones that are specialists. They like, maybe, you know, they like vegetables. They don't like that kind of vegetable. They like carrots. They like peas. It's like our kids, right? Well, microbes are the same. And so the more different, diverse plant life you have, you also have a greater diversity of microbial life under the soil as well. When we have bare soil, not only do we quickly lose moisture, because it actually evaporates from the surface of the soil much faster, but in fact, we are losing CO2, because the microbes need something to eat. They're going to break down the organic matter within the soil and then releasing that carbon dioxide out. They're releasing the carbon, because they actually respire just like us. They breathe out carbon dioxide. Plants take in the carbon dioxide. So some strategies that we can look at, as I mentioned already, looking at plant diversity, but also looking at the height. If we have a forage system, or maybe our front lawn or backyard, you know, often we have a lot of lawn or turf grass around, but I see it scalped. It's too low. Well, you have this root system that's showing the lower that grass is, the lower the roots are. That means when you have a period with low amount of water, that plant's roots aren't very deep. So they're not going deep enough to access water deep down in the system. Keeping those roots, or the upper part of the plant, a little bit taller really makes it much better and more resilient for that plant, has that deeper root system. And then when we're looking at a grazed system, similarly, moving those animals off faster so they're not scalping it down to the bottom, keeping those plants a little bit taller makes a difference in the resiliency of that location. And then a diversity of plants, not only for all the pollinators that would love all of this different variety here, but in actuality, look at all the different types of root architecture there is. There are so many different types of architecture of root systems. They each have their own little niche. They're able to access nutrients in various places. And that actually brings those, that up to the surface and those nutrients come up through into the root system. In the fall, those plants may die. Then those nutrients are staying there and recycled for the next year. And so some of those deep penetrating roots actually are there, able to really allow nutrients deeper in the soil to be brought back up to the surface. And then another thing that having all of those plants there, and not only is that feeding the microbes and helping with all of the above ground processes that happen, maybe it's feeding us or feeding other animals, but it increases the amount of water that can be held within the soil. This particular diagram here on the left shows, regardless of the type of soil you have, whether that's a sandy soil or all the way to a very kind of more clayey soil, by increasing the amount of soil organic matter, and in this case, it's from 1% up to 5%, it increased the amount of water that was able to be held within that soil. That's like an insurance policy for a little bit of drought. The higher the organic matter, the more water is held there and available for plants, regardless of the soil type. And then on the right-hand side is what we call an infiltration demo. And so we have these 5 different pans here, and those different pans are holding a soil that has had a different type of management practice. So the far left-hand pan, that is a traditional agriculture pan. That's actually kind of a no-till system. And then we have just a grass like a lawn. And then we have a continuously grazed, that middle one is like leave the animals out there all the time. And then we have a system that is rotationally grazed. And then we have the tilled, typical tilled soil. And then what those buckets there are demonstrating here are in fact showing you the amount that has run off. And so this is looking at when he has that rain going on there, how much water came off from the top of the soil. As you can see, the one on the right-hand side, that tilled system, lost an awful lot of water. And on top of that, it lost topsoil along with it and likely nutrients as well. But yet, the buckets on the bottom tell an even more important story. They're actually showing the amount of water that went through the soil. Those pans are only about 3 inches deep. Water that was able to infiltrate, get into the soil, and go through and come out into these buckets at the bottom. And if you notice, the one that lost the most water from erosion has no water in the bucket at all. No water in that rainstorm went in to the soil. It all ran off. But yet, all of the other buckets have a little bit of water in them. Some have clearer water in them, especially that rotationally grazed system. And some were just running off, like in the case of the no-till system, or running over. So that is kind of a great way to see how keeping those plants in there, keeping that organic matter in there, and not disturbing that soil through multiple tillage practices really does lead to holding on to much more water. And integrating animals into the system, I know there's this huge debate right now, eat meat, don't eat meat, all of these things. And I think it depends on where your location is and whether it works for you. However, there are ways to actually integrate animals into a system that actually improves the soil health rather than having them completely separated. Or in the case of this solar grazing system, you have solar panels there. They are not transparent solar panels, so you can't grow something underneath of them, but some of the plants will grow there. And now either you go in there with a mower and you're using some carbon burning tractor, or you sequester carbon and then you get an extra crop of maybe lamb, or you get wool, or perhaps even milk off of those sheep if they are the type that you can milk. And so integrating these systems allows us to do more in the same amount of space. And then looking at reducing inputs. And so obviously reducing inputs could hit on a lot of different things. Currently right now, I think there are lots of farmers that are figuring out ways to reduce their inputs because fertilizer prices are through the roof. But also when we take it onto a more small level within the soil is the microbial community, in fact, actually is disincentivized for creating a symbiotic relationship with a plant if we are putting in the fertilizer. What point is it for the plant to give off carbon and create a relationship and have to invest in that relationship through giving up some of its energy that it could put into its creating of its own self and creating a relationship with a microbe when it can access the nutrients on its own? And so there have been multiple research studies that have shown that when you add nitrogen and phosphorus to a soil, compared to a soil that has a living mulch there and not the inputs of that, in fact, the plants actually are able to access all of those nutrients through the relationship of the living mulch better. And then you have all the other benefits that come along with having that living plant matter there as well. And then, of course, variety. It is the spice of life. And so increasing biodiversity. And when I talk about that, I'm not just thinking about the biodiversity of what we see here above the ground, but as I've mentioned before, all of that different root architecture that is there. So you're not only increasing biodiversity of plants, you're going to increase the biodiversity of all of the different pollinators and insects that utilize all of those different plants and the niches that are among them, but also all of the microbial life that's there in that diversity as well. Reducing pesticide use is really important when we're talking about having something like this pollinator strip here, because if we are going to be trying to encourage pollinators to frequent all of these flowers, we have to be cognizant that we don't want to do them a disservice by going out there and applying something that is going to do them harm. And then by attracting not only these pollinators, but all the best beneficial insects that can help us in ensuring we are balancing the system above ground, and that helps us reduce inputs of any type of a pesticide. Sometimes, yes, I agree, that may be something that is the last ditch effort, and that is something that we look at when we have to save a crop so we can ensure that people eat. There has to be a better way if we bring back some balance to the system. I think that we can begin to start moving the needle and trying to reduce our use of certain types of pesticides. And so lastly, where is regenerative agriculture most beneficial? Well, I'm back to this diagram. You probably guess it is both beneficial in the agriculture as well as the household, but also it's likely also when we look at industry. And industry is also taking that into a circular kind of economy and looking at that as well. But when we talk about agriculture, we have to look at it from both a production standpoint as well as a use standpoint. And how can that really help us when we're talking about climate mitigation? So this diagram here has got a whole lot of arrows and lots of numbers and everything, but really what it is showing is the numbers that are in the blue are areas where carbon is stored. And so those are pools, as it were. Currently, actually, atmosphere needs to be corrected. It's more like 850 or higher. This is a older diagram from maybe last year or the year before. And so we have here, though, we have photosynthesis. So plants are at 120. That is where it is pulling down some of that carbon. So the plants, just the photosynthesis of plants are going to pull down carbon. But then, of course, plants actually respire. And so some of that carbon dioxide does go back out into the atmosphere, as well as oxygen. Lots of people don't understand plants emit oxygen as well as carbon dioxide. And then we have soil respiration. Really, that's the microbes that are breathing. And so we lose that. But if you look, 60 plus 60 equals 120. So this system is balanced with the amount of microbial life in a natural system that's balanced, along with the plant respiration, equals the amount of photosynthesis, as long as we have something actively actually photosynthesizing. And on top of that, the litter fall, if we leave the leaves where they are and allow some organic matter to stay on the soil, we don't just take it and rake it off and send it away, then in actuality, that increases the amount of carbon dioxide or carbon that can be stored, because that carbon there is more than the sum of these two here. So that's one solution, is to try to get it back down into the ground. And we must keep it there when we get it there. We need to limit the amount of disturbance of our soils. And so when we till a soil, we infuse lots of oxygen down into the soil. The microbes get a whole kind of a jump start of lots of oxygen, which means they're like super active. They're going to munch up a whole bunch of more of the carbon, which leads to more loss of carbon dioxide into the atmosphere. By kind of reducing our disturbance, the microbes are active, but not on hyperdrive. And so they're going to help keep some of the carbon there and not quickly release that carbon dioxide. And on top of that, they lead to, because they're breaking down this organic matter, it's not just made of carbon. It has lots of other ions in there, lots of nutrients, and it releases those nutrients. Well, you've just disturbed the soil. You have nothing actively growing there. If a rainfall comes, those microbes have quickly munched up lots of the organic matter that's in the soil. The rain comes and it takes away that nitrogen. Quickly off it goes, because nitrogen is easily leached from the soil within a rainfall, unless you have something actively there that is going to hold on to it. Yes, there is the cation exchange capacity that can hold on to some of one form of nitrogen in the form of ammonium, which is a positively charged ion. However, microbes like to take that ammonium and quickly make it into a nitrate, and that is negatively charged, and off it goes with the water. It's not held on. But if there's a plant there actively growing, that plant will take that nitrate, take it up into itself, hold on to it, and so it keeps it from being lost. And so by keeping it green, we really do help many different systems within the soil and really improve the health of the soil. But if we also had some perennial crops, we wouldn't need to disturb the soil. We integrate perennial crops into our systems. They're actively growing generally a lot longer period of time. And so that can really benefit by keeping some perennials into the system. And then increasing organic matter is in lots of different ways. You increase it through the use of compost, by mulching, and compost not only increase nutrients there, but mulching can also help hold water from evaporating from the soil surface, leaving the roots in the place. So even if you're like harvesting something like lettuce, leave the roots in there, let them just stay in there. They will decompose, they will feed the organic matter, and those nutrients will be released for the next plant. Looking at perennial alternatives, someplace like the Land Institute that's actually looking at, or has been creating, a perennial form of wheat called Kernza. That's just one tool in the toolbox of ways to be able to have a wheat crop, but yet it's perennial. We do not have to till it. We do not have to continually disturb the soil, but yet you can have a field of wheat. And then looking at polyculture systems, which is a mix of systems, looking at all sorts of different things similar to in this image. It's integrated, lots of different things which increase the biodiversity below the ground with the root systems, but also all the biodiversity of all the different insects there, probably attracting beneficial insects. And it's not a giant monocrop that's going to attract a large vast amount of insects that might come in and wipe it out, because there's all these little niches in there. It doesn't allow something to take hold in mass. And then of course, when I'm looking at in this talk, just talking about regenerative agriculture, that is just one very small part of the puzzle. And often we're talking regenerative, we need to be speaking about a regenerative agriculture food system. And so we take into account looking at all of these different aspects, from how the food gets to our stores, how it's processed, how it's marketed, and how we're able to access that, how we ourselves are preparing that, and then looking at the waste. Many crops, there are often, because of our parameters of how that food needs to look to get to the grocery store, there may be half the crop that's left in the field, never picked at all and never brought anywhere. And so figuring out ways that we can capture that resource would also, again, lead right into that regenerative agriculture, because those inputs have already been spent on that crop. And just wasting it is kind of wasting the resource that was put into it in the first place. And there are many different avenues to get some assistance in implementing that. If you are a farmer and you're kind of like, how can I do all this and afford it? I'm barely making ends meet. There are, in fact, some programs out there to help with adoptions of increasing cover crops, no-till, as well as other practices to steward the land. As well as within a community, often we have people within the soil and water conservation districts that can help implement practices, and maybe even as something like rain barrels as well. And reach out to your local cooperative extension office, because those folks are there to help guide you, collaborate with the research institutions, and bring you research-based information, and of which I am an agriculture extension agent. So we do this work because we want to make a difference and we want to help the community. And so with that, I'm going to end and take any questions that you have.